Another Falcon 9 upper stage suffers an issue and is left stranded in orbit. NASA's Viper might get a second chance to fly, and is an asteroid gonna hit the Earth in 8 years? As always, we'll cover all that and more this week in Spaceflight. It's becoming more and more common these days, but we've actually got a lot of lunar news this week. So much so, we've got to make a whole segment for it all. One of these lunar stories actually comes from two companies, Astrobotic and Astrolab, who have partnered to carry Astrolab's first lunar rover on Astrobotic's Griffin 1 lunar landing mission. The rover, called Flip, is a smaller version of the company's Flex rover, but still features the core components and subsystems needed for that larger version, which is the reason why Flip stands for Flex Lunar Innovation Platform. In the press release announcing the partnership, Astrolab reiterated it's still aiming to launch its Flex rover to the moon on a SpaceX Starship rocket within a 2-year window, opening as soon as December 2026. Astrobotic's Griffin 1 mission was originally planned to fly NASA's Viper rover to the lunar South Pole, but the agency decided to no longer continue with the project due to budget overruns and delays. So with that rover off the lander, Astrolab has taken the opportunity to put one of its own on the mission. NASA has, however, been trying to give its Viper rover a second chance by reaching out to private companies and research organizations that might use the rover instead of the agency. Now, we've been covering this process over the last few months, part of which involved issuing a request for information shortly after the announcement of the mission's cancellation. Thanks to that request for information, NASA was able to determine that there were indeed potentially viable partners to complete the mission. This week, NASA went one step further by actually issuing an announcement regarding partnership proposals. Next, the agency will start to work with those partners on a plan on how to best use Viper. After a study and selection process, the best suited partner will be chosen and the mission will move ahead, essentially giving Viper a second chance to fly to the moon. Meanwhile, Firefly's Blue Ghost lander continues to orbit the Earth, healthy and stable. This week, the company shared further pictures and video of the lander on its trip around our planet. Additionally, its payloads continue to transmit data back to Earth for scientists to analyze. According to Firefly, Blue Ghost is set to perform its translunar injection burn this week and park itself in lunar orbit just a few days later. The lander will remain in lunar orbit for a few weeks until March 2nd, when the conditions are right for its landing at Mare Crisium. In more lunar news, this week we learned that Thales Alenia Space will be building the airlock module for the Gateway space station that NASA plans to put in orbit near the moon. NASA wants to collaborate with other countries on Gateway, much like it did with the International Space Station. As a result, some of Gateway's modules will be provided by the European Space Agency, which also collaborates with the Japan Aerospace Exploration Agency on the main astronaut living space. The Canadian Space Agency will, of course, provide a robotic arm, just like it did for the ISS and shuttle, and finally, the United Arab Emirates will be responsible for the station's airlock module. NASA announced the collaboration early last year, and this week, the Mohammed bin Rashid Space Center signed a contract with Thales Alenia Space for the module's development. The module is planned to be 10 meters long and 4 meters wide and will weigh 10 tons at launch. Astronauts will use the module's airlock to step outside of Gateway for spacewalks, and its pressurized section will be used to store spacesuits and other equipment. In addition to spacewalks, it'll also be used for science experiments. The module will also be outfitted with a docking port for visiting vehicles. Now, it's no surprise that the Emirati Space Organization chose the Franco-Italian company to build their module, as Thales Alenia Space has a lot of experience with this kind of work. The company built several modules for the U.S. International Section on the ISS. It produces the pressure vessels for the Cygnus cargo spacecraft, and it's working on modules for the upcoming Axiom station as well. What's more, Thales Alenia was already involved with the development of 4 other Gateway modules, so this airlock is now the 5th on the company's to-do list. Alright, brace yourselves. Astronomers have found an asteroid that has a 2.3%, or 1 in 43, chance of colliding with Earth in December of 2032. Now yes, that's a small chance, but it's enough that astronomers, NASA, and the European Space Agency are now monitoring the situation closely. The asteroid was first discovered on December 27th by the NASA-funded ATLAS telescope in Chile. ATLAS is short for Asteroid Terrestrial Impact Last Alert System. Now named 2024 YR4, the asteroid is 40 to 100 meters in length and likely consists of rock and stony material. According to experts, it seems that this hunk of rock will be getting uncomfortably close to our home planet on December 22nd, 2032, and it has the potential to impact Earth at a velocity of 17 kilometers per second. As a result, it's now rated at level 3 on the Torino Impact Hazard Scale. This scale rates the risk of asteroid impacts based on the asteroid's size and its impact probability. A level 3 rating means that the asteroid has a chance of impacting larger than 1% and could do localized destruction if it does impact. This is a rating that definitely warrants attention from astronomers and the public. However, the rating could be adjusted later, maybe even back to 0. So how do astronomers determine if an asteroid is an actual threat? When an asteroid is first discovered, astronomers try to determine its trajectory and orbit around the Sun. With that, they can then extrapolate the path that the asteroid will take in the future. But it's hard to determine an asteroid's orbit with 100% certainty. As a result, any prediction of its future location won't be a precise point in space, but instead a range where the asteroid could be at that time. If that range overlaps with Earth, there's a chance that it's going to hit. We'll all be keeping an eye on Asteroid 2024 YR4, and as time goes on, astronomers will collect more and more data and be able to determine its orbit with increasing precision. And as a result, the radius of the area where the asteroid might pass in 2032 will narrow. And the chance of impact will also be updated. And that's exactly what happened this week. First, the probability of impact was estimated at 1 in 67, but now it's at 1 in 43. Wait. That's increasing. Wait, that doesn't sound good. Well, not so fast. It turns out that this is a normal effect of the prediction getting more and more precise, and it doesn't necessarily mean that we have to worry. So how does that work? Well, as the prediction gets more precise, the range of where the asteroid might end up gets smaller, which, yes, also means that a larger percentage of that range can overlap with Earth, so the chances of impact also increases. However, as long as the range keeps shrinking, it might eventually shrink so much that it no longer even overlaps with Earth at all, and suddenly the chance of impact is 0, because astronomers know the future position of the asteroid so precisely that they can confidently exclude the possibility of impact with our planet at all. Phew! We saw this exact phenomenon happen with asteroid Apophis in 2004. The odds of impact rose shortly after Apophis was discovered, bringing its Torino scale rating all the way up to a 4 for a potential impact in 2029. Eventually, we got much more precise data, and the chance of impact is now 0. Apophis is of no danger in the foreseeable future, but it did seem dangerous for a moment. In fact, Apophis and this other asteroid are the only asteroids ever discovered to have a Torino rating higher than 1. Now, there's a good chance that we will also see the probability of impact decrease for this asteroid that we're looking at today. The current estimates are based on 315 observations taken since the asteroid was first discovered, and of course, more observations keep rolling in. Unfortunately, the process is made harder by the asteroid's trajectory. It's currently moving pretty much in a straight line away from Earth, and this makes it difficult to determine its orbit precisely. Astronomers have a few more months to observe it, but it'll likely be too faint for Earth-based telescopes in April, and by that time, space-based telescopes might be our only chance until the asteroid gets close to Earth again in 2028. To get even more data, astronomers are also scouring archival images, as the asteroid may have accidentally been observed in the past. If they can find the asteroid in these old observations, they can be much more certain about the asteroid's path around the Sun and its odds of colliding with Earth in 2032. For now, we'll just have to wait and watch as the predictions get more and more precise, while astronomers are pointing their telescopes at the asteroid. Its probability of impact might increase, but it could also be reduced all the way to 0. We'll let you know in a future episode. And if you want to be notified whenever we cover asteroids and other space news, you know what to do. Hit the subscribe button, ring the bell, and why not give us a like too? A SpaceX Falcon 9 second stage has suffered an issue. At least, that's what the orbital tracking data suggests. This second stage in particular is the one for the Starlink Group 11-4 mission, which we'll cover later in the space traffic section. After releasing the satellites, the second stage was supposed to perform a deorbit burn to be disposed of during re-entry over the Pacific Ocean. Instead, the second stage was discovered to still be in orbit, so clearly that didn't happen. SpaceX hasn't really talked about this, nor is there any way of guessing what failed on this second stage to not perform this deorbit. orbit. And we do know that it was planned because there were both navigational and airspace notices warning about the second stage planning to deorbit over that area. If confirmed, this would be the third Falcon 9 second stage issue in roughly 6 months after a second stage leak in July of 2024 doomed the Starlink Group 9-3 mission, and another second stage deorbited over the wrong area of the Earth after the Crew 9 mission in September of last year. It's been days since the launch, so this second stage is no longer controllable as its batteries have drained and its liquid oxygen propellant has likely boiled off. Thankfully, it's in a really low orbit, which means it won't remain there for too long, as atmospheric drag will bring it back to Earth quickly. Not so thankfully, though, that re-entry will be uncontrolled and unpredictable. The second stage will re-enter anywhere on Earth that's between 53 degrees north and 53 degrees south, since its orbit is 53 degrees inclined relative to the equator. And that's a pretty big area. SpaceX suffered a similar issue in 2021 when another second stage got stuck in orbit after a Starlink mission. It eventually re-entered about 3 weeks later over the US Pacific Northwest, with debris reported in Oregon and Washington. That being said, and to be fair to SpaceX, this is just an issue with the second stage preventing the deorbiting of the stage. Many other companies and countries out there don't even bother doing this, even for low-energy missions, and they just leave many upper stages stranded in orbit. Now, one thing that some of you might be wondering is whether this will require an FAA investigation, and we've actually asked the FAA this. The agency replied back to NSF stating that, quote, all flight events occurred within the scope of SpaceX's licensed activities. So it appears that, at least for the moment, there won't need to be an investigation. In fact, SpaceX launched 2 more times after that Starlink launch this week, with one of the missions requiring 5 burns of the Falcon 9 upper stage to complete its mission, and all were carried out successfully. Now we'll take a glimpse at some other stories across space, starting with India's brand new NVS-02 satellite, which is stuck in the wrong orbit. The Indian Space Research Organization, or ISRO, launched the satellite last week on its Geosynchronous Satellite Launch Vehicle, also known as GSLV. The launch itself was successful, and the rocket placed the satellite into a geosynchronous transfer orbit. From there, the satellite was supposed to raise its own orbit to eventually end up in its destination orbit. Unfortunately, that didn't happen. The spacecraft failed to light its thrusters and is now stuck in its transfer orbit. According to ISRO, one of the oxidizer valves in the satellite's propulsion system refused to open when it was supposed to, and the thrusters couldn't fire as a result. The satellite's purpose was to provide navigation services to mobile phones, like GPS, but only in India. While NVS-02 may never reach its intended destination, there is, however, a chance it will still be able to do its job. It was able to correctly deploy its solar panels, and they're generating all the power required for the navigation system to operate. So ISRO is now looking into ways to use the satellite for navigation from its current elliptical orbit. The French space agency CNES wants a fully reusable rocket. According to the agency, Starship 6 flight in November proved that a reusable second stage was feasible when it softly touched down at its targeted location in the Indian Ocean. And now, CNES wants one of its own. For that, it's launched the Des Mesures project, which is short for what translates to Reusable Upper Stage Demonstration Project in French, and it's called for industry proposals for a reusable upper stage demonstration. The project's first phase only seeks the development of concepts, but if these concepts seem promising, the next stages will include building a test vehicle and, eventually, performing a demonstration flight. All in all, CNES wants a fully reusable replacement for Ariane 6 that's capable of lifting 20 tons into low Earth orbit, but these first demonstrations may be carried out at a smaller scale. NASA's Europa Clipper spacecraft has been on its way to Jupiter's moon Europa for a few months now since its launch on October 14th, and during this time, engineers have been firing up the spacecraft's instruments to ensure that they're all operating as intended. Among these instruments was a pair of star trackers that were tested in early December. The images taken by these star trackers are the first images sent back by Europa Clipper, and this week, NASA shared them with the public. Now, normally, the star trackers aren't supposed to send their images back to Earth. Their purpose is typically to determine a spacecraft's orientation by observing its position relative to known stars in the sky. But Europa Clipper uses this data for another crucial task, pointing its science instruments at their subjects and its antennas back at Earth. Without these star trackers, Clipper wouldn't be able to do science or send its results back home. So this time, it sent back the images from the star trackers themselves so engineers could check that these all-important systems had survived launch. Europa Clipper is currently traveling through space at a brisk 27 kilometers per second. In just a few weeks, on March 1st, it'll fly by Mars and use the red planet's gravity to speed up. If all goes well, Europa Clipper is set to arrive at Jupiter in 2030. This week, ULA CEO Tory shared further updates on social media about the company's progress at Space Launch Complex 3 in Vandenberg. Ever since the last launch of an Atlas V from that West Coast pad in November of 2022, ULA has been working on modernizing the complex and adapting it for the company's Vulcan Centaur rocket. This included the addition of extra liquid hydrogen and liquid oxygen storage, since Vulcan needs more of those, as well as the addition of liquid methane storage tanks for the first time at their site. In Tory's latest update, he shared pictures of the arrival and transportation of the second liquid methane tank for the launch pad's tank farm. According to the Post, the tank weighs about 1 million pounds empty and 3 million pounds full, which translates to about 450 metric tons empty and about 1,360 metric tons full. This in turn would mean that the tank can hold about 900 tons of liquid methane, which is quite a lot considering that this is a second tank at the launch site. To put it all into perspective, 1,800 metric tons of liquid methane is more liquid methane than what can even fit inside a Super Heavy booster. And this is for a rocket that is quite a bit smaller than that. Safe to say, ULA will have lots of methane to spare for launches at Slick 3. There also was a leadership change at Roscosmos this week. The Kremlin dismissed General Director Yuri Borisov less than 3 years after he replaced Dmitry Rogozin in 2022. During Borisov's tenure, Roscosmos introduced ambitious plans for a new Russian space station and collaboration with China for a moon base. But it seems Roscosmos hasn't achieved all that much beyond just making new plans. The Russian space program has been in decline for a long time, and the war in Ukraine didn't improve their situation. Many of Russia's plans for space are constantly facing delays and budget cuts, and in 2023, the Luna 25 moonlander also failed to deliver, instead crashing into the lunar surface. The Kremlin has chosen Deputy Transport Minister Dmitry Bakhanov as Borisov's replacement. Bakhanov is suited to this role as he used to be the head of satellite communications company GoNets. Reportedly, Rogozin commented on his successor's replacement, complaining that Borisov failed to deliver on a Russian version of Starlink, and considering the new guy's expertise, that could be exactly what's coming. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. Since we're now into a new month, let's start off by taking a look at the stats from last month. In January, we had 21 launches worldwide, very much on par with January of last year, which had 22. The most active launch operator was, to no one's surprise, SpaceX, with 13 launches of its Falcon 9 rocket. China came in at number 2 on the list with 6 launches, and India placed 3rd with only 1. The launch cadence so far also matches the numbers that we saw in 2024, with the world being on track for 260 launches by the end of the year. Now, it's likely that the reason that there's not an uptick yet in that rhythm is because China paused its launches for a couple of weeks during the Chinese New Year. At the same time, SpaceX may also have had a maintenance period at its most active launch site, Space Launch Complex 40, which also saw a really rare 2-week gap between launches in the middle of January. Without these, it's likely that January could have been a lot more active. But let's now go to the first launch of February with the SpaceX Falcon 9 rocket. I know, your jaw's on the floor, right? Liftoff took place on February 1st at 23:02 UTC from Space Launch Complex 4 East in California. The mission was carrying 22 Starlink V2 mini satellites to low Earth orbit. This is the mission that we talked about earlier in the show that had its second stage left stranded in orbit despite having planned for its deorbit and disposal. The first stage for this mission, B-1075, was flying for a 17th time, and it successfully landed on SpaceX's drone ship, Of Course I Still Love You. Next, we go over to Japan, which had its first launch of the year this week. The mission started on February 2nd at 8:30 UTC with an H3 rocket lifting off from the Tanegashima Space Center. The rocket was carrying the Michibiki 6 satellite into a geosynchronous transfer orbit. Michibiki 6 is the latest satellite of Japan's quasi-zenith satellite system, a regional navigation satellite system that serves as augmentation of the usual global navigation satellite system. This regional system uses a variety of satellites placed in geostationary orbit and in highly elliptical orbits around Earth that also have orbital periods of about 1 day. In this arrangement, the satellites in geostationary orbits will be orbiting over East Asia, while those in the highly elliptical but still geosynchronous orbits will have figure-8 ground tracks over the Earth. The satellites in this latter arrangement would be launched such that at least one is always near the top of that figure-8 ground track, which would be located over Japan. Michibiki 6 also carries on board a space domain awareness payload from the U.S. Space Force. This is the first of 2 launches as a part of a partnership between the U.S. Department of Defense and Japan. Coming back to the US, we had 2 very foggy launches taking place on the same day from Florida. The first one, Starlink Group 12-3, took off on February 4th at 10:15 UTC from Space Launch Complex 40, carrying 8 Starlink V2 Mini and 13 Starlink direct-to-cell satellites. Despite the fog, the launch happened without a hitch, and veteran booster B1069 was able to log another successful flight, its 21st launch and landing, after touching down on SpaceX's drone ship Just Read the Instructions. That same day, also from the US but a lot less foggy, was the launch of Blue Origin's New Shepard rocket on the NS-29 mission. Liftoff took place at 1700 UTC from Blue Origin's Launch Site 1 in West Texas. The mission carried 30 payloads from NASA and other organizations on board. Notably for this mission, the New Shepard capsule initiated a spin of 11 revolutions per minute after booster separation to simulate lunar gravity for the payloads flying inside. Most of the payloads carried on New Shepard needed that simulated lunar gravity as they were related to studying conditions in that environment. For example, the Lunar G Combustion Investigation, or LUCI, from NASA's Glenn Research Center aims to study how materials combust in lunar gravity compared to Earth's gravity. For this mission, Blue Origin decided to use its newest booster, Tail 5, which was flying for a second time on this mission. The capsule used for this flight was the RSS H.G. Wells, which is Blue Origin's own New Shepard capsule dedicated to cargo flights. This was the 11th flight for this capsule, and while one of its parachutes initially didn't inflate fully, it eventually did, right before touchdown on the West Texas desert. Later that day, another Falcon 9 took off from Florida, this time from Launch Complex 39A at 2313 UTC, carrying a pair of WorldView Legion satellites from Maxar into low Earth orbit. The satellites were the 5th and 6th WorldView Legion satellites to be launched as part of Maxar's constellation of latest generation commercial intelligence satellites. This final pair features high-resolution multispectral imaging capabilities of the Earth. With 6 satellites around the Earth, 2 in sun-synchronous orbit and 4 in mid-inclination low Earth orbits, Maxar has the ability to image the same area more often than with a traditional Earth observation satellite constellation based only in sun-synchronous orbit. The 2 satellites were placed in 2 different orbits by Falcon 9, which necessitated a long-duration mission extension kit on the Falcon 9's second stage for this mission. The booster for this mission, B1086, was a young one, flying for only its 4th time on this mission. The stage returned back to the Cape about 8 minutes after launch for a landing at SpaceX's Landing Zone 1. This week also featured this year's first launch from Russia with a Soyuz 2.1V rocket taking off from Plesetsk. The mission started on February 5th at 4 o'clock UTC, and it carried a few classified payloads into a polar orbit for the Russian Ministry of Defense. So far, 5 objects have been tracked in orbit from this launch, which could be that both the Soyuz second stage and Volga upper stage were left in orbit, in which case it would be 3 satellites. And there's also still the possibility that other satellites could pop up on future orbital tracking as well as a result of this launch. State-owned news site RIA Novosti claims that this was the last launch of this Soyuz variant, which uses the NK-33 engine on its first stage. The engine was first developed in the 1970s as an upgrade for the first stage engine of the N-1 rocket, but it never flew as such, and many of them were left unused. After the fall of the Soviet Union, Aerojet decided to purchase some of them, and the rest remained in Russian hands. Since Russia lacked a light-lift launch vehicle of its own, it decided to create one by removing the side boosters of a Soyuz rocket and fitting an NK-33 engine to the central booster, creating the Soyuz 2.1V rocket. Since there were a limited number of these engines available, this configuration of the Soyuz rocket wouldn't last long, and, if the report's correct, this may have just been its last flight. Going into next week, we'll also have the first launch of the year from Rocket Lab, if orbital mechanics allows. The Electron mission, called IoT for You and Me, was supposed to launch this past week, but it had to be aborted due to conflicts with orbital traffic in space for the dedicated launch time needed for this mission. Rocket Lab has reset for a launch this weekend on February 8th at 2043 UTC. Let's hope that this time no satellites are in Electron's way. Next week, we'll also have a trio of Starlink launches, starting with Starlink Group 1110 from Vandenberg. The 4-hour launch window for this flight is set to open on February 9th at 25 minutes past midnight UTC. In between those Starlink launches, we might have the debut launch of the Changzheng 8A rocket from China. Liftoff could happen on February 11th within a roughly 50-minute window opening at 9:53 UTC. The other 2 Starlink launches next week will both be Group 12 launches from Florida. Starlink Group 1218 has a 4-hour launch window opening on February 11th at 1700 UTC. And roughly 3 days later, it'll be Starlink Group 12-8's turn from the same pad within a 4-hour launch window that opens on February 14th at 1726 UTC. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and we'll see you all again next week to recap this week in spaceflight.